you hear me at the back?
Yes.
I don't want to use the microphone. Okay? But there are plenty of spaces in the front. You know, we are not in the school, so I'm not draining you. So you can come to the front. Okay? Before I start, maybe some of you already saw this presentation, so I hope it will be not boring for you. But who saw these slides already? Who saw these graphics? Nobody? At least you don't count. Okay. I don't want to make a spec sheet reading for this presentation, so I will try to tell you the story what software-defined storage is. Software-defined storage is not a product. I think you mentioned that, but it's a concept, and how IBM fits into the strategy. Okay? I hope it will not be boring. So let's first take a look what software-defined storage actually is. There are 5 key attributes of software-defined storage. First of thing, it is a software. That means we are running on a commodity processors. This means commodity processors like Intel, ARM, Power, not the special design chips. We have to virtualize resources which we use because that's how we can achieve full control of everything. We have to provide APIs for remote management because software-defined storage is a part of a bigger family called software-defined environments. It should give us ease of management because nobody will do something if it's complex. And of course, it should provide us that we can manage all in storage infrastructure without taking it down. Okay. So when you move to software-defined approach, your infrastructure will be running all the time, even when you need to replace the component inside it. Okay. So all the solutions which comply to this are the true software-defined storage solutions. Okay. Say, who is defining in the tender the workload profile?
If you want to run a database, it will be defined by I/O. If you want to run some, let's say, non-I/O consuming servers, it will be defined by storage capacity.
But still, you will have to say how many IOs, even if it's only 10. Because I can give you 100 terabyte disk, this is just an example, or 10 terabyte disks. So, are you defining your tenders by workload profiles like IOPS already? Because I still see tenders all over the place where I get the number of disks, the number of ports, the cache size, the number of controllers. Okay. Why I'm talking about this? Because everything starts from the business requirements. Okay? You have business requirements for your storage. And the 3 key business requirements are how critical the data is, so availability, this is one of them. How fast can I deploy and how can I explore my data, so how fast I can get to the data. So the workload profile is important. Okay. The service level agreement is very important. And all this brings us to the cost and economics of storage. Because I assume everybody wants to save, right? Usually storage is a tool in a business. Infrastructure is there for business, not business is there for infrastructure. Okay? Sometimes IT departments are not thinking the same, but that's how it is. So we have financial requirements we have to meet, right? Infrastructure is a cost of our business. And business has a cost model for everything, including the infrastructure. So with the classical approach, we grow steadily normally. We spend, normally, the idea of software-defined storage and cloud storage is to actually save when you acquire. Because you can reuse, you can easily manage, you have less footprint. So all this brings down your CapEx. And also, this brings down your OpEx. So the whole idea of software-defined storage is to bring down the cost of storage. Not just acquisition, also the running cost. While meeting the SLAs. Not saving the money to break the SLA. Fulfilling the SLA and saving and optimizing. And how do we achieve all this? We achieve all this by doing the software-defined storage and the key components of software-defined storage. Virtualization, tiering, some kind of data saving technologies like compression, replication, end-to-end management, and by using flash in storage. Okay. I will talk about flash a bit later. So let's look at the classical data center, where you have your applications which have the SLAs. Storage SLA is just one part of SLA of the whole application, right? These storage applications are connected to your network. You have some kind of storage behind the classical approach. You can have different tiers in the box, or you can have separate systems to tier around. Okay. Potentially, you have your second data center for disaster recovery purposes, and for this reason, you need to replicate the data, either on host level or on storage level. And if you have multiple vendors, this means you need to manage multiple vendor replication. Do you see yourself here? What does this mean? Everything is complex to manage. Actually, you can always do things. It's just a matter how much effort you have to put in. And when you have complexity like this, in any area you can make mistakes. The whole idea of software-defined storage is that we separate the management from the resource. What is the resource in storage? It's a capacity and performance. All the rest is logic, right? So when we do this, we have a single point of management. Okay? We can add any system at the back. We can grow horizontally and vertically. We can add flash to speed up. We can even build new environments, completely dedicated. Still we manage everything up here. We can compress environments, either single environment or everything. And the key thing is we didn't touch the server, because this layer sits between our resources and the servers. That means the risk of doing all this is much lower than the risk when you have a classical storage approach. So you have a layer which is actually protecting the server against the changes in the web. Okay? So this is very important because you are easily meeting your SLAs. Okay? So we do this to address 6 key operational challenges in storage infrastructure. Do you see yourself here? Or do you see something missing? When you manage it, I'm not talking about the cost challenge. Cost challenge is always here. I'm talking about operational challenge. We all want to be highly available, right? We all want to be able to react fast on performance problems. We all want to be able to easily grow. We all want to be able to easily replace what we have with new stuff. Because things, when get old, they broke. Okay. You can make a nice deal with vendor and ask for 7 years of maintenance and get a good deal for that. But you have to know that the physical drives, and this will be even more common now with flash, are increasing the error rate after the 3rd, 4th year. So it's not just about that you are replacing them, you also have higher risk that multiple things will fail in the system. So have the ability to easily change the components is decreasing your risk. Everybody wants to have ease of management, so when you need to provision new capacity, you should have it in minutes, not in days or hours. And everybody wants to make easy backup. I'm not referring to the backup which you had before, but here I'm referring to the backup of big data sets, which are usually backed up on the storage level. Okay. So, do you see this? Is this something you also feel? Or is there something missing? Or you think this is bullshit? Okay? So, did I miss something? Is there any other operational aspect which you see in your infrastructure? Like I said, we are not in the school. So, don't be afraid to say something. Yes or no? Does this make sense? You can say it doesn't, you know, we are in a free world. So SDS, or software-defined storage, is actually addressing all these 6 bullets, plus the bullet of efficient cost for the infrastructure, right? So from IBM perspective, there are a couple of solutions which fit into this concept. And we all know that storage is block and file, right? And when we talk about file storage, we also think about object storage and so on. So we have portfolio which covers both sides. Unfortunately, things are not converged yet completely because of the reasons how the native of block and the native of files are. So our solution for block is called virtual storage center. Okay. This solution has everything what we talked before. It has a virtualizer and it has a management software which manages this virtualizer to provide all the functionality we talked about. Okay. All these 5 key elements. So it's an appliance which runs the virtualization software. That means we are controlling all the IOPS for us. We have the management interface. We have the backup integration software and a unique feature, analytics engine. I will have some details on that later on, but in short, this means that we are able to monitor the storage performance and usage and tell you how it should be placed on the back end, defined on SLAs. So for example, if you define the application to be sitting in SLA 1, but you later see it does not need to be there, analytics will tell you this application is not consuming what you wanted, it consumes much less, move it to somewhere else. So potentially this engine can redistribute your load to the optimal places in the infrastructure. And what does this mean? You save the money. Okay. The file solution is called Spectrum Scale. It has the same philosophy, virtualizing engine, and of course management and all the stuff as it is in the block area. There is a key difference, and this difference is you can integrate the tape as a tier. In a block storage, you can integrate just the disk. I think you had the presentation before me which was saying this backup will kill the tape, but it's not like this. So if you have the system which can integrate the tape, you can even have the tiering automated all the way to the tape. Okay. And this is possible because file storage is sequential. Block storage is random. That's why you don't have tape in the block tape. I will focus now on some use cases which were made for block, but they apply also for this. Maybe one thing I need to talk about here is the file solution has the cloud integration. That means you can extend your on-premises file to the cloud. Okay, you can get storage from Amazon or from IBM software or anywhere, and you will have a single file system across this. The same solution we are bringing to block next year. So we will give you a chance that you have a block extension to cloud. So how do we do this? First and foremost, the most important thing is when you go to software-defined approaches that you have a good monitoring. There is no good infrastructure without good monitoring, because with monitoring, you know what you have. How many of you can tell how much you are using in your storage, on capacity-wise, performance-wise? Only one. Two. Okay. Why monitoring is so important? First, you know what you have. You can act on the problems. Secondly, if you know what you have, and if you know historically what you have, you can predict what you need to buy. Okay. You are not just simply going by the rule of thumb and say, now I have X amount of drives, I will now buy X plus half of X. So monitoring is very important. And if you remember this picture, when you have a complex environment, you monitor on all the points. When you have SDS, it's a single monitoring interface. Because this is now I/O control. We know all the data from the front to the back. Okay? So we don't need to go to the back. Only go to the back when we are over the baseline. So in SDS approach, what you do, you baseline a new backend which you bring in, And then you can compare the baseline to what you have. As long as you are below baseline, there is no need to look inside here for the purpose. So you have everything on a single layer and combine this with the analytics engine. Okay. So that's how it looks like. Your dashboard, you have the whole view of your infrastructure. You have, let's say, some quick data available, how much you are using, and you have a central point of management. Of course, this management software can also look at the back boxes, but this is only. So with the monitoring in place and with the analytics engine on top of this, you can really optimize everything and start using your software-defined storage in full capacity. Okay. So how we do it? It is not a rip and replace approach. Okay. It can be gradual. So you can come in and gradually move your infrastructure to it. So we are not asking you that you get rid of everything and put this inside. Okay. So classically, this is your infrastructure. If you want now to move the block virtualization, you need to bring the devices inside, you install the devices, you configure them, and you start moving. And you move application by application until it's done. And once it's there, it's very easy to add anything. And now let's take a look at some use cases. The first one, how do you traditionally do a new box, a new storage system? You have to buy it, you bring it in. Usually, you prefer to stick to the same vendor, so you don't even need to change the drivers on the storage side, on the server side, and you start to move the data around. Okay. So you are interfering your server. Who is using change procedures? With this, change procedure will require interference to the server side. So approvals from the applications and the server operators. Okay. And one other thing is you are moving data from here to here, so you're actually utilizing the server for data movement. That means at that time you are using CPU on that server. And what CPU means? You pay for software. Okay. Because if you need CPU just to move the data, for application that sit there, this is wasted CPU. And then you decommission. Usually the customers I work with, they are afraid of migrations. Okay. They don't like migrations because they bring changes in their environment. And that's why they don't like to change the vendor. Not just because they have to learn how to manage the storage, but because they have to change everything on server side to support that. Of course, with certain server operating system, this is easier than with the others. Still, it poses a risk, and it takes time. Okay. And you are done. So, how you do it when you have a software-defined approach? You bring the box, you run the migration, and go for a beer. Okay. No impact on server. Server will not even know that you are doing it. So your change management will be much easier. And you can migrate anytime you want. And you don't care what box you get here, because you manage storage here. And this system has a single time setup. Initial setup only. One more benefit with this is that in a classical approach, people tend to upgrade system as long as they can because they don't want to change them. Upgrading is okay, but it brings certain, let's say, challenges into the financials of this. Because every time you upgrade one system, you are prolonging the depreciation of that system. Okay. When you have this approach, you just buy building block when you need it. You need some new capacity, buy new building block. So no upgrades inside the box. Just upgrades in the blocks. It's like Lego. You need to build something new, just get some more Legos. So you add here or you add here. You are not tied to any of this. Okay? So that's the first pretty important use case. Okay? The second case is because you control everything here, you can do tiering here, you can do compression on that level. So it's very easy to speed up all the systems which already exist by adding flash systems, or it's very easy to compress. And actually we have the clients who are doing this, compressing the whole environments. Instead of buying additional storage, they move to SDS with compression, which by the way from IBM is inline compression with minimum performance impact. Usually we actually improve performance. Why do we improve performance? Because if you get 100 megabytes per second here and you have compression 2 to 1, only 50 megabytes goes back. That means less load on the back end. Automatically you are faster. So this is another good TCO case. And one more important thing when we talk about Lego. When you upgrade existing systems with different disk technologies, you will not fully utilize that system because old type systems were not designed for flash. Old type systems were designed for normal rotational disks. So let's say if I have a system which can support 1,000 drives or 500 drives, if I put inside this system 500 flash drives, I will kill controllers on that system. Ideally would be that I put at the back system for the disks I need. So if I need flash, I only take flash system. I don't take the hybrid system. Of course, this implies that this layer is extremely fast, which it is. Okay. The third use case is clones and snaps. Why do you usually use the clones and snaps? For backup, testing, quality assurance, product development, right? So if you have your system inside the high end, you need usually to clone in the same system. Of course, there are some vendors who can do that. You attach externally something and clone to that, but experience shows not a lot of people are doing this because of performance. So with SDS, you can clone to a cheaper disk. So again, you save money, right? So you can either use more for production, or you have smaller production system. And on top of this, you can compress everything. So you save again. And saving is not just acquisition cost. Saving is also the space cost, the power cost, and the cooling cost. Maybe this is not an issue here, but I'm meeting many clients who have already now the issues with the data center power. The fourth use case, disaster recovery. If you want to implement disaster recovery with a classical storage, you need to stick with the same vendor. And usually you need to stick with the same system. With applying disaster recovery technologies on software-defined layer, you can use whatever you want. Our software-defined storage supports all high-end replication technologies, synchronous replication, asynchronous replication for low bandwidth, with protocol optimization. Okay. So it's very easy to implement. One unique feature is stretching. You can stretch a single system across two sites. Usually this is a metro solution, which provides a transparent high availability solution. This is not replacement for disaster recovery, but it is more than HA because it is not in the same location. Okay? So you have a transparent access, so whenever site fails, you can still run. The next evolution of this is Hyperswap, which we just announced actually at the end of last year, actually even further improving the way how we handle availability. So we again stretch the systems across sites, and regardless what happens on any of the sites, we have active access, so no interference on the server. No software needed to manage the failover. Everything is purely transferred to the server. Okay. Important thing to say here is, this is platform agnostic. So we support all operating systems. machine and classical replication. Classical replication, the key difference is you still have your data locally. Your data on the secondary side is only waiting for the problem. When you stretch, you can have access to both copies. What does this mean? Double read performance. Because we are doing this in a metro area, the latency between the sides is not extreme. It's usually milliseconds, or even less. So you have a double access. That means you can implement such a solution also for an application which cannot be clustered. Okay? You have double read performance, no downtime when you fail over, because here when you fail over, there is application restart. Here, if you lose your storage, you can just exit from here. Of course, somebody will say, that's all fine, but this is still one system. Correct, it is. It is a 5-9 system, but still it is one system. And I said this is not replacement for disaster recovery. This is high availability solution. So to have a serious disaster recovery, you have solution like this. So you make yourself HA locally, and you make your disaster recovery. Because you don't want to go to disaster recovery just because of one component failure. You can have disaster recovery like this, but that means every time the storage system goes down, you will go to disaster zone. So this makes disaster management much easier. And if you know storage, such function is the function of high-end. Three-side solution, it's only high-end. We can actually give you 4 sides, because you have chance to have 2 storage systems talking to each other. And we actually have quite a lot of customers doing this. Having HA in the city, we are to another city and having again HA in the city. Okay. Another use case is preferred read. Maybe this is a bit obsolete, but still quite commonly used. If you have a classical storage behind SDS layer and you want to speed it up, you can bring a flash in your environment. You can simply make a copy and redirect the reads to that flash. You still have your data here in synchronous copy, so you still feel sure it's on your original system, but you speed it up dramatically because you have a flash. And it's double benefit because now you only write here. The most critical workloads for storage are random reads and sequential reads, right? So if you offload random from here, this will be faster for writes because he's not handling reads anymore. This use case is also interesting when you have smaller capacities of flash you want to use. You can maybe use rate 0 here for flash. Flash is still fairly expensive, so if you have flash with rate, you have a lot of overhead. It's more capacities, right? So this is a case where you can overcome this and save some money. Okay? So you said to me that you are all doing this when you open the tables. How are you able to get this data? How much time does it take to you? Before you go to tender and provide workload profile. How easy can you do this today? Easy, not easy, medium, not, I cannot do it at all. I would not be surprised if you had this. Or you will make a number just like this. I wanted to show you that with our management software, which I mentioned before, you can do 4 clicks and you will get workload profile which you can copy paste into an RFP. Okay? You log onto the system, select your system, select the time period, select the parameters you want to display, and you get the table like this. Okay? And this can go straight to RFP. It's a real data. Okay? It's a real data.
But this is different when you have different block size that you return.
You can do this for different applications. Still with 4 clicks for every application. You can group your rules into application rules and then do this for them. This is an example of the system, but if you want to break it down, you can break it down. Okay. So if the application has different growth sets, you will have different sets for all the applications. Still for only 4 clicks for each application. Okay. What does this mean? That you can accurately acquire what you need. You know, especially, I see many RFPs with the numbers like, we want 500,000 IOs. Okay. There are customers who need this. But some people just say it because they don't know to define what they need. And 500,000 is not the same with 4K or 64K or 34K. So it's important that you know what you have. And as you saw it, if you would use our virtual storage center, which has this component included, you could get this data very easily. So your next tender will be much better. It's especially important when you start to transition to the flash technology. In the past, you know, when you had disks, you could make a rule of thumb. Yes, today I'm using 500 disks, I'm growing 50%, I go to 750 of the same type of disk. What you will do with flash? You will say to vendor, give me this amount of chips, or give me this amount of modules. Okay. It's better to give him the workload profile, then he has to do the size for that profile. Another way how to reduce the cost in environment. Proper service level placement. With our software for management, you can define service levels. You can align these service levels to the storage attributes. And when the user provisions and he selects service level, the system will automatically place him to the right place. Okay. So service levels and user provision included in that software. This again means that you align your storage usage to the proper capacity and performance. Okay. And something unique to our software-defined storage, system will monitor what you have. So you have defined your service levels. System will monitor your applications. And based on analytics of this data, system will tell you where this data has to go. So he will optimally suggest you in which service level each application has to go, based on the historical load of that application. And you can then also use automated placement. Okay. So if you use our SDS, the analytic engine will say to SDS, please move with the data around. Okay. And SDS layer will use the same technology which I showed in the box replacement to move the data around. So potentially, in a certain point, you will have the data on the right place. And you will see if you are actually using the infrastructure. Maybe you will figure out after half the year that you bought flash which is not used at all. Or that you bought something which is not used. So you can start optimizing much easier. So this again takes you to the savings. Okay. How we can do this? We can do this because we have a technology which is called volume level tiering. I'm sure you are all aware of the in-volume tiering. Okay. When you move the hot blocks to the faster disk or vice versa. Of course, in-volume tiering is not a solution for everything, because there is no algorithm in the vault which can predict when I will press enter to do some query. And I never know where my data is, because I think I'm in a hybrid pool, right? Everything will be fast. I didn't touch my data for 40 days, I believe it will be fast. I press enter, it will take some time that this data comes to the flash disk. If you do it on volume level, you always know in which SLA you are. Okay. So you have no, this is more psychological than technology. So our analytics engine is looking at the whole volume level moving this to a proper tier. And inside each volume, we can still use volume tiering, in volume tiering, right? So this is not excluded. This is unique feature. Okay. Another use case, very interesting use case, is how to save money and achieve the same availability as high-end. Classical high-end on your left side, right? Full redundant environment, 5 nines, 5 to 6 nines means 5 minutes of unplanned downtime yearly. You can build your high-end solution with the components which are not all 5 nines. Of course, you need to have 5 nines on the software-defined layer, but at the back you can use storage which has 4 nines. And this together brings you practically the 5-9 system. 1 second difference in downtime, probably a couple of 100,000 difference in the cost. And another benefit is we have 2 copies, that means double read performance while everything is working. Okay. And again, it's a Lego approach. I need to change something, I can change it easily. And you know the old joke, how the cleaning lady comes to data center and the power cord is disconnected? Here it's a single power cord. Here there are 2 power cords because there are 2 systems. Okay. So very easy way how to save money and achieve the same SLA on even method. Okay. An example of applying this is like this. This is fairly good tender. Okay, we have IOPS, but we don't have a block size, right? We want a lot of cloning, we want a lot of ports, and usual answer to this standard would be high-end systems. With software defined, we can separate clones to mid-range. We need much less ports because our ports works much better, so we in total save a lot of money. Already on the list price. Okay. Not just on the specialty. Important difference is how we handle the licensing. In a classical storage, license is attached to serial number. Okay. When you buy new storage, you buy new license. I'm not saying this is accurate split, but just for an example. In a software defined, you have a software license which is acquired in a subscription model like any software, and you buy the back storage which only does RAID, nothing else. Because all the logic is here. So the license is owned by the customer. It's not attached to the box. So when you buy a new box at the back, license is still with you. When you buy a new appliance here, license is still with you. License is not attached to appliance. It's attached to the customer. Okay. And this can bring savings too. To wrap it up, IBM Semi Controller and IBM Spectrum virtualized software can convert any storage infrastructure to software defined. Okay, so it's not rip and replace approach. How much time do we have? 10? Okay. Now a couple of words about why Flash. And actually why Flash in combination with software defined. And again, this is how we do it. Maybe not other vendors are doing the same. But for us, Flash is pure performance. Okay. The idea of Flash is performance. So if I already have the logic on software defined, I don't need the logic on Flash. I just want the pure performance. And that's why Flash is a perfect fit to software defined approach. So why I would buy Flash? When you go, I would like that you remember these 4 red numbers. IBM Flash is very small. In 2U, we have 57 terabyte usable capacity. No other vendor can do this. Usable capacity. Okay. I don't even, okay, there are a lot of IOPS here, but I don't want to talk about it. Okay. So, huge usable capacity in 2U. Huge. Extreme performance, extreme access time. 2 to 3 times faster than the closest competition. Okay? And extremely low power consumption. So these are 4 attributes which are actually factors why you would buy flash. Okay? I will show you in the real cases why, and in the business case why. Okay? So if we look at storage, we have, and if we look at from performance and price, flash is of course the most expensive and the fastest. But combining with software defined, it can bring the cost down, especially by using compression. Because compression on top of the flash is driving the cost of the flash down. And the good thing with IBM approach is you don't need to compress everything. You can compress just what you need. So you can still have ultra fast flash stuff and you can compress stuff. Okay? So why flash? What is so special? It has extremely fast latency. Okay, it's fast. And there is one more thing which I explain on the next slide. It's extremely small footprint. If you rent, is anybody renting the data center somewhere in Europe? Or you have everything global? How cheap it is? It is not so cheap, right?
Depends what you want from the data center.
But you pay for every, you pay per 1 U, right?
No, we pay for cabin.
For the rent.
Yeah, let's say we have a closed room.
Okay. So the payment model varies, but
It's really expensive.
it's not cheap. I mean, I work with clients, I'm in Central Europe region, right? And a lot of clients have data centers in Europe, in West Europe. This is not cheap. Okay? It's not cheap. I can tell you that we sell flash to the clients just to cover, we could cover the cost of the rack going from 42U to 2U, and this paid out the flash for the storage. Not in 1 month, but in a period of 2 to 3 years, right? So it's very small, it's very low electricity consumption. I will not have the live demo. I will just show you the picture, okay? So you all know this, right? Hair dryer, right? This is portable hair dryer. If you look at your hair dryer at home, it will have 2 kilowatts probably.
Yes.
Okay. So flash has 700 watts. This is like 2 portable hair dryers. This is practically nothing. Why this is possible? Because we use memory, we don't use rotation, right? Why the disk? The classical, if you look at classical record disks, tier 1 system, usually the power consumption around 3 to 4 kilowatts. And on top of this, 3 to 4 kilowatts for air conditioning. Now you make your math. Even power is not for free. It's cheap, but it's not for free. Okay. So very low power consumption. And the most important thing is extremely fast. If you look at classical server, when the application is doing some work, the server usually has the processor is doing 3 main things. Running the code, running some system code, and waiting for storage, and waiting for storage, and waiting for storage. So if you have out of your I/O processing 60% of waits, that means you are paying something for nothing. Okay. Unless you have software license based on transactions, you throw money through your window. Okay. So what we do with flash, we bring this down to 0 or to very low number. This means we can reduce the wait time. I'm coming back to the use case for this. Okay? So let me show you a couple of examples why the clients are buying flash. Of course, there are cases where clients need flash simply because of speed. But those cases are not so many. So let's take a look why the clients bought flash. Okay. An example of client A, they were having some warehouse application, so doing ETL, right, the warehouse load. We did analysis, we saw that there will be a lot of speed improvement, right? CPU utilization will go up quite a lot, almost double, okay? And everything improved. So ETL time was going down from 5 to 2 hours. Already quite important if you want to do this ETL frequently. Usually warehouse is used by managers. The managers are important guys, they want to have stuff fast, right? But why these guys actually got? Can you think about why they got it? I'm asking you, so probably, obviously it's not the speed. What could be the reason? It was the power. They could not get more power to data center. They would need to go to the electricity company to get more transforming power on the transformators and bring this to them. First, this would cost quite a lot of money because they would need to upgrade the transformer just for them. So instead of doing that, they replaced some existing storage with flash.
Yeah, but most of the modern data centers are calculated for rotating drives, not for SSDs. So this is when you're replacing with SSDs, it's nothing. It's benefit only for you, not for the data center itself.
This client has its own data center. So
this client has
it is full. It is full, right? So power-wise, it's full. So they cannot bring any more devices.
Okay.
Yes, I agree. If you're in the shared model, they will just give you price for that. Here, the pure issue was I want to collect my money. I need to collect my money. The third client, again, performance issues. Okay. Again, analysis, improvement quite a lot. The reason for flash was they could not afford application re-engineering. And simply buying faster infrastructure made the things working okay. Otherwise, they would need to get the software vendor to fix this. And we all
companies doing that.
Huh?
Most of the companies doing that.
Yes. Because you know what is usually. The guys who don't admit their problem are application developers and networking, right? Nothing is wrong with those two guys. Everything is wrong on the storage and on the server. Yes, this is good for us. But sometimes you come to the limit where you cannot do it and you have to go back to application. Right? So, all of those guys had some reason to do it, right? But how Flash can still help you, even if you don't fit into this, right? By translating this speed into the business case. That means we save money somewhere else, right? We invest in Flash to save somewhere else. Okay. So how can we do this? Usually when you go to IT manager of the company and say, I have a great technology called Flash, this will solve a lot of your problems, you will save money on top of this, the guy will say back to you, I'm paying majority of my budget for software. You now want to sell me some hardware? How do you plan to save? Is it true for you? Usually hardware is even less than 30%. So if we optimize the 30%, this would be neglectable compared to 70%, right? So how can I do this? Actually, I'm bringing your 70% down. Okay. You remember the wait time. Okay. If I'm using slow storage, I have to do a lot of waiting. That means I'm spending a lot of licensing for waiting. If I have fast storage, I can go down. This is a real example. The client was having application on 120 cores. This means software license for every core. I'm almost there. Okay. With Flash, we brought him down to 70 cores. Just for database, he was saving $500,000 a year. How much you think was the cost of Flash? It was less than this. Okay. So in 1 year, we have return on investment. there are other benefits, like things run faster, less maintenance for servers, and so on and so forth. Okay? So if you look at my 3 examples, they are all based on the same thing. CPU utilization improvement. That means reduction of the number of CPU power. That means reduction of the cost for software. Okay? So another example, 48 CPUs before, 24 after. Okay? I'm skipping this one. Here is the calculation. So this is our initial total 48, new total 24, and now the TCO. My savings, okay, not just database license, also some other software, electricity maintenance, and just by this, I'm covering the investment. And on top of this, I'm also getting intangible results. Things are faster, things are more reliable, shorter batch, and people don't need to bother so much with troubleshooting performance. Okay? So the flash can clearly bring the benefits in terms of saving money on software support. Okay? Here is the example of solution, which is quite common. Software-defined storage layer, flash component, and still you can use rotational disk in the same solution. What is important is to, I would say, you can expect that on the long run, not so long run, but in a couple of years, this will disappear. Everything will be flashed and taped. Yeah. And the tape will be still there with you. Because you will not store everything on flash. The reason why we don't have everything on flash today is supply, not price. Okay. Manufacturing cost is not expensive, it's a supply issue. We all have phones, right? Everybody has flash on the phone. Apple can come and buy all flash from the ship. And then we are better. Luckily, IBM switched to flash vendor. Okay, we are now working with Micron. Not just because Apple can buy Toshiba, but because Micron is using tradings from us. Toshiba didn't work with us. We can get much deeper in the flash cell with Micron technology and our tradings than with Toshiba, and this gives us the possibility to cut the cost on flash production. That's why we can do this 57 terabytes. And when I'm talking about the flash itself, flash is already penetrating in tier 1. Especially in combination with compression, because we can practically match the price of tier 1 storage in the total TCO with our virtualized and flash bundle. Okay? Okay, we did cover this. So I just want to recap 5 more minutes. Just want to recap. How many of you heard about IBM Spectrum? Except partners. You didn't? Okay. Our marketing is not doing a good job. So, IBM Spectrum is IBM's software family. And you were seeing through my slides, I was talking about Spectrum Virtualized, Spectrum Control, Spectrum Scale. So Spectrum is the family which was announced this year to consolidate all the portfolio into a single family. Okay? Spectrum has 6 components. Spectrum Control is a management software. Spectrum Protect is a backup. Spectrum Archive is a linear tape file system integration. Okay. Spectrum Virtualize, former SVC, software only, not appliance. Spectrum Scale, file, and Spectrum Accelerate, XIV is a software. It's another software-defined approach from IBM. So remember about Spectrum family. We can cover end-to-end software-defined approach. Okay, I skip this. The big picture, so software-defined sits in the big picture of orchestration. So you have a data control layer and you have a data access service layer. In our components, Virtualize, Accelerate, Scale, and Archive is our data access layer. control and protect is our data control and protection. Okay? And virtual storage center, which we talked about, has a control pane and data access pane. And to wrap it up, all these to address these challenges. And the seventh one, everything has to be cheap. But not cheap in a way that it will not work. It's price efficient. So this slide I don't like, but I put in just to show you what we are releasing in the latest software version, which is coming out tomorrow. Okay. With software defined, we are actually releasing every 6 months new version, bringing new features every 6 months. And this one is quite important. We will announce encryption on a software-defined layer. What does this mean? You can encrypt everything which goes to the I/O layer. You don't need to buy storage which can encrypt. This is becoming quite top. The second thing is the clustered rate. What does this mean? Faster rate rebuild. You know how long does it take classically to rebuild 6 terabyte drive? 1 day or more. With this, you're down to less than an hour. We are bringing in improvements in our hyperscope, and maybe the really important thing is we will have now built-in compressed estimator tool. So if you have software-defined environment, it will tell you how much you save if you start using compression. Because up till now, you had to measure this on the server side, which is sometimes quite complex because you need to go from server to server to server. Now you will see it on this layer. And we are bringing additional support for VMware with virtual volumes. So why IBM? We are doing this for 11 years, actually 12 years now. We were the first in the industry in 2003. Luckily, we are also ranked #1. We support any storage vendor in the back, you can imagine. Single function, single stack, all the functions in single stack. So all these attributes, all other vendors are catching up behind us. And we have the fastest flash. So don't remember, 2U, 57 terabytes, 150 microseconds, 675 watts. Any questions?
Where to sign the contract?
Go to you, right? You are the right person for that.
How much it costs the appliance?
The flash appliance,
The flash.
I don't know the list prices, the terabyte prices in the range of enterprise storage. So if you go with compression plus flash, the terabyte cost is the same like tier 1 enterprise. With 2-to-1 compression, which we guarantee. So I think Gartner number for enterprise storage is around 2,500, 2,700 per terabyte, including support and maintenance. But better, just you contact me, right?
Because